Okay, folks. Today we're working on calculating slope. So we're going to kind of like generalize a formula for slope. We use this to find the slope between 2 points when you don't have a graph, right? Like on our warm up, we could put those 2 points on the graph and calculate rise over run. We could also do it with a table. This method is more similar to using a table. We're going to be using that same idea of subtracting to find the difference between the vertical change and the horizontal change, but it's like a formalized formula, if that makes sense. So the idea here is we have these 2 points, and we're going to find the slope between them using slope formula. Okay. Now every point consists of an x and a y. The first number is always the x. The second number is always the y. So I like to label them like so. And then this is my first point, so I'm going to call this x1 and y1. This is my second point, so I'm going to call it x2 and y2. Okay. Now all I've done is basically taken all 4 of these numbers and I'm kind of separating them out into whether they're x's and y's and whether the first x and the first y, or second x and second y. And so when we look at the formula, we've got kind of these 4 spots right here, right? And I've got it kind of located right here. And so the idea here is your y's are going to go on top. Okay. So this y2 is going to go here. This y1 is going to go here. Our x2 is going to go here, and our x1 is going to go here. Okay, so basically we're just taking all 4 of these numbers and putting them in these 4 spots. Okay, so then my y2 goes first. That's going to be here at 6. My y1 is 3. That's going to go here, just like that. My x2 is 5, right, just like here, and then my x1 is here. Okay. Another way you can think about this is you can take these, you can stack them up. So I've got 5 and 6. Actually, let me do, 5 and 6 on top, and then 1 and 3 on the bottom. And then what I'm going to do is I'm going to kind of tip this whole thing over. So then this whole thing tips over. The 6 and the 3 will be on top. Okay. And then the 5 and 1 will be on the bottom. As I kind of tip this whole thing over, kind of like to visualize what's happening, as it tips, the 6 and the 3 stay on top, the 5 and the 1 go on the bottom, and then you just subtract them. So the idea is you stack them, you tip them, and then you subtract them. So stack, tip, subtract. Okay, so this is kind of like the formal mathematical way of doing it. This is kind of the shortcut of like you stack them up, you tip them over, and then you subtract them. So anyway, I've got this 6 minus 3, and I've got this 5 minus 1. That's going to be 3 on top and 4 on the bottom. So the slope between those 2 points is 3/4. Okay. If we were to look at this as a graph, let me see what I got on this here. Let me get rid of what I got on it currently. Burp, burp. I'll pull this graph over here. This is just Desmos right here. Let me zoom in a bit so it's not quite so cluttered. I'm going to put these 2 points on here. I'm going to put 1, 3, 1, 3, and then 5, 6. Okay. And I've got the distance here. I'm basically going up 3 boxes. I'm going right 4 boxes, and that's exactly what we did there, 3/4. Okay. So you just use this when you don't have a graph. If you have a graph, you can do rise over run. But if you don't, you kind of got to do this, okay? So just as a reminder, I have it up here, 2, 5, and 8, 6. This is my x1, y1, x2, y2. So I get 6 and 5 on top, and then 8 and 2 on the bottom. And then I subtract. I end up getting 1/6. Okay? 6 minus 5 is 1. 8 minus 2 is 6, so my slope there is 1/6. Between these 2 lines means go up 1 and right 6. Okay, so that's just using the slope formula. I'll kind of do my tipping method here. So I'll stack them up vertically. So 1, 9, 4, 2, and then I'll kind of tip them over. So basically, if I tip them, let me kind of do it like this. I've got 1. I'll erase a little bit. 1, 9 here as I tip them and rotate them, and then 4, 2. And if I do that, I can see that I have 9 and 2 on top, and 1 and 4 on the bottom. So then I'm going to just got them right here, 1 minus 4, and I end up with 7. And then I have a negative 3 down here. So I have a slope of negative 7/3. Let me pop that on the graph here so that we can see kind of that that's going to be a negative line right there. I got 4, 2, and then I got, what was it? 1, 9. Okay, so I got these 2 points. I'm going down 7, so 1, 2, 3, 4, 5, 6, 7, and then right 3. And it's a negative graph, so the slope will be that negative 7/3, okay? So I got 4, 1, and 5, 6. I'm going to stack them, tip them, and subtract, okay? So I stack them, 4, 1. Doesn't matter kind of which ones you put on top. I realize I did this one second, but I've got 5, 6. Okay, and then I'm gonna, which way did I rotate? I do this so that I can put 4, 1 here, and then 5, 6 here. Just make sure that your y's are on top, right? So these are my y's, so they gotta go on top. Right there, yep, there we go. So then 1 minus 6, and then 4 minus 5. I'm gonna get negative 5 over negative 1. And if you have 2 negatives, they're going to cancel out, and it's just going to be a positive 5. Okay. Yep. So then I got 3, 10, and 5, 6. I'm going to do the slope formula right here. So I'm going to say 6 minus 10 on top. So that's x1, y1, x2, y2. So 6 minus 10, and then 5 minus 3. I end up with a negative 4 over 2, which is just going to simplify to a slope of negative 2. Okay. I could show you all these on Desmos if you wanted to, but that's what it's going to show you. Okay. So that's how we calculate slope. Now, we haven't really talked about slopes of horizontal and vertical lines. So we'll just do kind of a real quick thing here. So we got the slope of this line. Well, I got these 2 points right here. I got 3/4 and 7/4. So I'm just going to do them here. Okay, I'm going to stack them. 7/4, 3/4. Then I'm gonna rotate them. So I get 7/4 here, and then 3/4. Then I'm gonna subtract them. So 3 minus 7 over 4 minus 4. Oh. Quick. Let's make sure, because we got to actually rotate them this way so that these are going to be on top. So it's going to be, hold on. Let's see. Actually, I'm just going to do slope formula. Now I'm getting all mixed up. So I'm going to do 4 minus 4 on top, because that's my x1, y1, and x2, y2. So then I'm going to do 4 minus 4 on top. Yeah. Maybe that, I came up with that stacking tipping thing. I got to make sure I'm rotating the right way. So I got to think about that. So 7 minus 3 on the bottom. I end up with 0, and then 7 minus 3 is 4. It's got a slope of 0 over 4. If I do that division, then I'm just going to do this on the calculator. 0 divided by 4 is going to give us 0. So we get a slope of 0. So that's actually true for all horizontal lines, okay? So slope of 0, because your run is going to be 0, right? There's no, right? It's like this. It never actually tips up, so you're never going to have a vertical change, right? The vertical change is always constant as 0. Okay, so, and then when we look at the points, we can see that the y values are the same, and so the y values are always going to be 4. So because of that, our equation is going to be y equals 4. Okay, now when we go to our vertical lines right here, I got 6 and 8, and I got 6 and 1, so I'll put them over here, 6 and 8, and then 6 and 1. Let's do the stacking. Let's try the stacking. So I got 6, 8, 6, 1. Now when I rotate them, I'm going to rotate them this way, and I'm going to have going to put the 6's on top, will it? Oh, I want to rotate the other way. That's why. You always rotate this way. That's it. So now I've got 6 and 8, and then 6 and 1. So now I'm going to do my subtraction. I've got 8 minus 1 on top, and then 6 minus 6 on the bottom. So I'm going to end up with 7 divided by 0. Now what happens when you get 7 divided by 0 is a little weird. Whenever you put it into a calculator, you're going to get an error because you can't divide by 0. Okay, so this has a slope that is undefined. Okay, so all vertical lines have a slope of undefined because the horizontal change is always constant as a 0, and since that's on the bottom of the fraction, you're going to get undefined. The horizontal change is always constant as a 0. Okay, and when you look at the points, you'll notice that the x's are the same, so they're just going to stay the same for the whole thing. So you can also think about this as it crosses the x-axis at 6, so x equals 6. And that's that.